Hello, my name's Andy. This is examples of how Kotlin can make your Java code better. Has anyone here seen the web series Video Game High School? It's highly recommended. It's like a fantasy scenario where there's this elite high school for playing video games, and all the cool kids do the first-person shooters, and then there's some people that do the beat 'em ups and stuff like that who are reasonably cool. And then somewhere deep buried in a basement are some very sort of ill-looking people clustered around little mobile devices, and they are the social gamers, and they're the kind of outcasts in this. I feel a little bit like the JVM talks, the social gamers of ACCU. But welcome. So this talk came out of I've been trying to advocate a little bit for Kotlin usage at my work. And a question that was asked when I started recommending this was, isn't this just syntactic sugar? Isn't this effectively the same thing as Java? So this talk is intended to provide you a little bit of ammunition to answer that question, possibly by saying yes, possibly by saying no, but by saying that what it gives you matters. So whether or not it's syntactic sugar, it's something that can make your code better. So in order to try and show that, what I've done is gone through code that we have at our work and then sort of mercilessly hacked it to protect the guilty, and then shown you how changing that code into Kotlin can make it better in ways that I believe are materially better. So first, I will talk very briefly about what Kotlin is. Then I will deviate briefly onto things that I think are good in code. And then we'll go through some examples, as I said, of code that I believe is better when it's written in Kotlin. So first of all, what is Kotlin? Kotlin is a programming language. It's highly compatible with Java. It compiles to the same runtime as Java, and it also feels a bit like Java when you write code in it. But you can, I assert, write less code in Kotlin to achieve the same thing that you would achieve in Java, and also, crucially, I think, better code. And really, this talk is about better code. So in order for us to talk about what is better code, I need to explain to you what I think better code looks like. Some things that are good. So I think it's good to write code that separates things that represent values or quantities or things that you manipulate from algorithms that work on them. One way you might be able to identify this is that things, values, don't tend to have many dependencies, and the algorithms that operate on them will bring together multiple dependencies in order to combine objects together and things like that. That might be one way of thinking about that. If you look at that and think Andy doesn't like object-oriented programming, well, maybe you're right. Maybe not. I mean, it's maybe objects are good for making values that make sense coherently within themselves, not so good for the kind of things we've used them for. Other things that I think are good, immutability, by which I mean stuff that you know doesn't change, preferably as much stuff as possible that doesn't change, but something's got to change. In particular, not knowing what state a particular thing might be in at a particular time. So if we can remove that complexity, that is good. Other things I like, catching errors at compile time rather than at runtime. Particularly catching errors that I know how to react to fix. Other things that I think are good, declarative style, by which I mean generally writing code that expresses how something should be rather than what you should do in order to get something to be that way. And I also think having less code in general is better than having more code. So if you agree with some of those things, maybe some of these examples will convince you. So what Kotlin does is it makes it a little bit easier to do things that I think are good, and it makes it a little bit more visible when you do things that I think are bad. So what I'm not claiming in this talk is that Kotlin is the language I would have designed if I could design any language. But I am claiming that it's materially better than Java if you make use of its facilities, which I think is quite a bold claim. So in the Java community over the decades, we have developed some patterns that we think are normal ways of writing Java. Some of those patterns, maybe not all, are patterns that are the ways of writing good Java. So one of the ways that Kotlin makes our life better is it takes these patterns, which hopefully we follow because they're good, and makes it easy to write them in a way that means you can't make a mistake in those patterns, and encourages you to follow the good patterns. So in my experience of reading Kotlin code is, oh yeah, that's the way I would have done it in Java, but I don't have to type so much. So now we move on to some examples. This is the British musician example. I didn't have anything else to put on that slide. Here's an example. So, as I said, this is stuff that comes from our code, but I've hacked it around so it doesn't look quite so awful. And I've renamed things in some cases. Like, for example, this class isn't called thing in our production code base. But we have, in our code, we have lots of things that represent just groups of data. So this is a value class. It's a thing which has a name and a description. And in Java, following the kind of standard way of doing things in Java, if you have a name and a description, then you need a field, which is a name and a description. You need a constructor, which takes a name and a description. And in the constructor, you need to set the name and the description. And then you need a getter for your name and a getter for your description. And then, of course, if you want to be able to write tests that check whether one thing is equal to another thing, you need to have an equals method. And if you have an equals method, you need to have a hashcode method. This is our hashcode method. Is that correct? What does it even mean for a hashcode method to be correct? Nobody knows. Maybe it's correct. Or maybe returning 1 would be correct. This is the equals method. It's very straightforward. Is that correct? Could be. Sudden? Yeah, there are tests for this code. All the code that I'm showing here has tests written in Java that are identical for the Kotlin example and the Java example, and they all pass. So obviously you might also want a toString method, especially if you're writing tests. You want to check that you want your error messages from your tests to be useful. So you might write a toString method. Maybe that's correct. So I counted from writing that code that the word name is mentioned 14 times in that class. And I believe that every single time the word name is mentioned, it has exactly the same semantic meaning, which is, in me, I have a name. Right? There is a property of this object called name, and we just have to repeat that over and over to Java until we've finally convinced it that we have a property called name. 13 mentions are all lowercase, and one of them has a capital N. So would you like to see the Kotlin equivalent to this code? The Kotlin equivalent to that code is one line. It passes all the same tests. So this is a perfect example of what I was saying, that we take a pattern that works in Java, but is sometimes laborious and easy to get wrong, or at least has the potential to get wrong. And we turn it into something so trivial that you might even be tempted not to write tests for that at all. But by writing tests, I have confirmed for you that it does have all the same behaviors you would expect. And the way this works is by adding that one word data at the beginning before the class definition, which says, please generate all the stuff that I would like a data class or a value class to have, like getters and setters, or rather getters and not setters in this case because this is an immutable object, but an equals and a hash code implemented correctly, constructor and so on. Make sense? Yes.
Given that this is a one-liner from Kotlin, you could argue that you no need to test it.
Yeah, so the comment is given that this is a one-liner, maybe there's no need to test it. I mean, it's certainly true once you're confident in your language, there's no need to test that your language is doing what it promised. So your focus of your testing would be different, right? It would be, does it have the right properties in or something like that? Yeah, so we can reduce the test code as well as the production code potentially. Cool. Maybe I should stop there. I mean, if we just had this, it would be good, right? Next example. These examples are going to get progressively more complicated, the code that you have to read, right? But you don't have to read it all. Okay, so this is a class which represents a message. And a message always has an ID, and it may also have some other properties. But they may be null. So what I've tried to do with these examples is I've tried to make them like the best Java that I can write that does this thing. So, or at least this example. But some of the others, they're more to demonstrate how bad things can get. But so in this case, I have a personal hatred of builder objects. But I have a love of immutable things. And the builder pattern is used often to let you build something with optional properties and then sort of press it, like pressing a CD and say, here's my immutable object once I've built it up using a builder. But there is another pattern that you can use instead, which is used in our real code in some places, which is that we have an immutable object. And if I want to build up optional parameters one by one, I simply make one and then make another one, which is like the first one, but has this extra property in it. So this is the pattern that you're seeing here. So it can look a bit like a builder. If I want to make a message that is for a particular customer, first I make a message and give its ID, and then I call the .forCustomer method, and that returns me a new message that has two properties set in it, the ID and the customer, and so on. So this is a way of having an immutable class, but not having a horrible builder class, which is a copy of your other class, but mutable. With me so far? So this is how you use it. At the end of that, you've got a message which has an ID and a to and a customer. You might not like that, but I mean, how much do you like builders? Anyway, so this is all of this stuff about either use a builder or use something weird like this is all because we want the message to have some of these parameters be optional, and you can't do that in Java. But in Kotlin, you can just write this. And technically, this is a one-liner again. But it's a slightly longer line. So this directly expresses what I meant when I wrote all that other code. A message has one mandatory property and multiple optional properties. And you can construct a message using named parameters. So this is syntactic sugar. But boy, is it tasty sugar. And you're writing code where you want to say, all I want to say is I want a message with this ID, this to, and this customer. And in Kotlin, I just write that down. I think it helps. And it helps particularly because there aren't likely to be any bugs in the way Kotlin understands this, whereas who knows what bugs I put into my machinery to try and achieve the same thing. Cool, so let's move on to worse code and more exciting features. So this is a class that works out a score for a customer, as in how how exciting we think this customer is. I realized when I was writing these slides that this is quite a creepy thing to do, and I did take some production code and produce this class, but the production code does nothing like this whatsoever. So I just wanted to point out that we at Open Market don't do this creepy thing. But anyway, so the way it works out how exciting it thinks the customer is, it has some words which it thinks if the customer's looking for this word, then that customer is interesting, presumably because the thing they're looking for is more expensive. So here we build a map. This is one relatively standard way of building up a fixed map of things in Java, which I don't like. And then this is where we use it. So when a request from a customer comes in the score request method, we update the score for that customer based on the word that they used in that request. So we look up what word they asked for, find out its value, and then add that onto their existing score. And when I was writing this, I discovered the merge method on a hash map. It's really cool. This is how it works. So that just means add on to what's there, or if it's not there, just put that value in. And then later on, you could ask what score the person has. Fair enough? Look like reasonable code? When I was writing a unit test for this code, one line of it crashed. Anyone care to guess why? Yeah. Misspelt one of the words. Lavender isn't spelt like that. So our code crashed with an unchecked exception. Let me go back. So to show you the line of code, that code crashes because the get method returns null because there's nothing in the map for that word. So now we're trying to add a null to a number, or we're trying to put null into our map. That's a null pointer exception. So let's have a look at a bit of Kotlin that does something similar. This, by the way, is how you can build a map in a more declarative style in Kotlin. I must say that the word to there makes me feel a bit uncomfortable. If you don't like that, you can just make a pair. So actually, A to B is just syntactic sugar for pair of A and B. Pair being the name of an ordinary class. Once you get used to it, it's okay. It would be nice if it looked more like Python or something, right? So declarative way of building a map, not as nasty as what I was doing in Java. And here's our implementation of using that map. By the way, that map's declared outside of the class because not everything has to be in a class in Kotlin. But yeah, so the code looks really similar to before. Instead of calling .get, we're using square bracket operator, but it has the same meaning. Code's almost the same, but it isn't going to crash. The reason why it isn't going to crash is because we've added a little bit of code here because the compiler made us, which handles the case where that what's coming back from the square bracket operator is null. So what we're using here is the Elvis operator, because if you turn your head on one side, it sort of looks like Elvis. Right? So what that means is either that thing you just said, or if it's null, this thing. So Kotlin comes with quite a lot of machinery that makes handling nulls, once you're used to it. I mean, at the moment, this might look weird if you're not used to it. But there's only maybe 4 operators you need to understand how they work, which means that you're forced by the compiler to handle the fact that it might be null, because the type system expresses whether or not something can be null. And then it gives you really clean ways of handling that in whatever way you want. So you might want to say, like this, if it's null, give me this other thing. Or you might want to chain a whole bunch of calls together and just let the null propagate all the way out. But if it's not null, keep on doing more stuff and things like that. And that can be expressed in Kotlin in ways that are compact enough that you actually will do it, which is important. But also it's enforced that you do something. So even if you choose to do the awful thing and just say, throw a null pointer exception if it's null, you can say that too, but you have to use an exclamation mark, which makes it look bad. So you feel bad. So it's remarkable how easy it is to deal with the null case when you're given a bit of custom machinery that works with it. And I think if this was the only thing that Kotlin gave me, it would be enough. So the type system, again, in quite a compact and understandable way, lets you declare whether or not something might be null by just putting a question mark after the name of your class. You're saying this could be a string or it could be null. And if you don't put the question mark, it could not be null. When you interface with Java code, you have to handle the fact that anything could be null. And the type system helps you. Or it helps you say, no, I'm going to be bad and just ignore it, if you must. Okay, other things. So this is an example to allow me to talk a little bit about the immutability stuff you get in Kotlin. So here's a bit of Java code. I said the examples are going to get more complicated over time and worse. So this is a real bug I found in our real code. We have a class which can emit a message, or and in this case, the method we're looking at handles a message that's come in, and it needs to do something, and it's also timing what it does at the same time. So can you see the bug in this code? Yes, what's the bug? Give me one of the bugs. Start, yeah, that's right. So the word start is used twice in this code for two entirely different things. So the time that you get at the end is going to be the time since 1970, the length of time since 1970, which is probably not what you wanted when you were trying to time this code. So in Java has a mechanism that makes it less likely that you're going to make this mistake, or gives us at least one way we could have escaped it in this case, which is that if we declare those variables which we know are never going to change final, then if we try and change them, Java will tell us with a compile error. That's good, right? So Java gives us that, but we don't use it because it's too many letters. But it's okay because Kotlin fixes that because we use fewer letters. Seriously, like we don't put final in any of our method parameter declarations because it's too many letters. But in Kotlin you spell final something, val, which is the same length as var, and var is frowned upon and val is smiled upon. So if you write this code, this Kotlin code, and you declare start in the default way that you would declare it in Kotlin, you'll get approximately the same behavior that we got when we declared it final in Java, although it's not actually the same, I discovered when I did it, because actually Kotlin is doing something else here that I hadn't thought of, which is that it's making a new scope when it makes a for loop. So actually it wasn't even a bug anyway in Kotlin when I translated this code to Kotlin, because start is actually a different name inside that for loop, so it would have been fine. But also you get a warning from the Kotlin compiler saying, you probably shouldn't do this. So maybe that's even better, I don't know. So yeah, the point here is that some classes of bug can be fixed by making things that don't change final. And in Kotlin, that's the default way of doing stuff. It's actually a tip for, I don't know whether anyone here occasionally has to deal with methods that are a bit longer than they would have liked, with a few more moving parts than they would have expected if they'd written the code from scratch. But sometimes I have to do that. And going through the variables and making them final is one way of picking up where they change or whether they change. It might just help you unpick one of those things. Okay, so the main point is Kotlin's way of making variables is sane by default. You declare them as a val, and then when you realize, oh no, I have to change this thing, you change it to var at that point. It makes your code better. Okay, handling cases. Anyone have code like this? This is classic code for open market. Because we have messages sort of flowing through our system, which might have various different statuses. So we have been given a status code, and based on the status code that this external system gave us, we want to reattempt delivery of this message later. But the type of error that we've received will affect when we want to reattempt this message, or maybe we give up. So we write a switch, which is a C programming concept that made it through into Java with no modification. Although that's changing, right? It's going to get more complicated, as mature languages do. So this code is fine. It also follows a pattern that some people use, which is only have one return in your code, which was probably invented for good reasons, but for code like this, it looks crazy. And we deal with the different cases. We set our variable later. We return that value, so long as we remember to put break in, which we sometimes do. So similar code in Kotlin might look something like this. So in this code, you can't forget break. You can also slightly more directly express what you meant. When you grouping together cases, it's not because you accidentally missed out a break, it's because you explicitly group them together with commas separating them. So from those points of view, it's harder to make mistakes. Yeah, I'll get on to the other part later. Also, we might actually feel that switching just based on those numbers wasn't quite what we wanted to do. And a better way of expressing what we mean would be something like this. So that gives me an opportunity to introduce the sealed class concept in Kotlin. So a sealed class is something like an algebraic type in other languages. It's a way of saying the only classes that are ever going to extend this response class is this sealed list of classes. So when you say that a class is sealed, you know that by the time we reach the end of that physical source code file, you've seen all the possible subclasses of that class. And the compiler is able to use that information. So when we have a when expression like this, the compiler is able to give us a compile error if we didn't handle one of the possible cases, because the compiler knows all possible cases. Does that make sense? Yeah, so we can express in words the type of error and then handle each type of error in a different way. So the word is here means is an instance of. And also on the right-hand side of the arrow, if you use the variable response, it will have the type So the compiler has understood the is fast error thing, and now on the right-hand side, if you use the variable response, its type is fast error, which is a bit weird. But I mean, it works. It's great. It's a very pragmatic way of taking very Java-like code, but removing a pattern that you sometimes have to follow. It works for null checks as well. So often you will have some code which does handle a case where something's null, and you'll say, if it's null, do this, else do that. And inside the else, you need to, that's a bad example. And then in Kotlin code, once you're inside the else, you know it's not null. So you no longer have to use the Elvis operator or something like that, because the compiler has understood your if and seen that. Now, I don't know how clever that is and how far into your code it can get and still know that. Maybe it's fine. Maybe it covers everything that could ever happen. But that seems like the halting problem. I don't know. But at least in the normal case where you do if it's null, do this, if it's not null, do this, you no longer have to handle the null case because the compiler can see it's happen. Similarly, in code like this, if you're looking through and saying if the type is this, if the type is this, in Java you then have to cast it to that type before you can actually use it as that type. But in this code, if we used response on the right-hand side, the compiler would already know what type it is. So that's a really brilliant piece of functionality that you get from algebraic types in languages that have them. It's maybe slightly weird the way it looks in Kotlin. Going back to the other example, the part that I skipped over is that this when expression is an expression, not just a statement. So the switch statement in Java is a statement. You can't return switch something. Similarly, the if statement in Java is a statement. In Kotlin, both if and when can be expressions, which means that they can give you back a value which you immediately use for something else. In this case, we're getting the value from that and just returning it immediately. So we've successfully refactored our code to have only one return statement, but without the weird convolutions we went through to do that in the previous code, which didn't actually make our code any better. Here it really does make our code better, I argue. So we can return the value of an expression. We could even nest an if inside the right-hand side of the when, and we'd be returning the result of that if. And when you treat a when or an if or something like that as an expression in Kotlin, it enforces that every possible case gets handled. So that means, presumably for a number, you always need to have an else case. Certainly for an if, you always need to have an else case. If it's a sealed class, you need to have handled all the possible subclasses. Make sense? Means that we can write things in a slightly more declarative style than a switch. Okay, moving on to constructors. So this is a bit of a journey for me, because I've been making statements about constructors boldly, and then changing my mind and then boldly making a new statement about constructors. At one point, I thought that every class should only ever have one constructor. At one point, I thought that there should be no overloading of any methods ever. I don't know, but maybe I still think that. But seeing how Kotlin did it made me realize that I was following a pattern something like this myself. So here we have a class called requester, which you can construct by just passing in the information that build that class, or you can construct it by missing out some stuff that it needs, which it will then build for you, or by passing in information that it's going to use to construct the class that it uses inside itself. So in some fundamental sense, the top constructor is very closely associated with the definition of this class. What this class is, or what it holds or represents, is a schema, host, and a client. But it has a few ways of making a schema, host, and a client, which are kind of just convenient methods for you. And then so sometimes people follow a pattern of having a static method called from user and password or something. So in order to express the fact that one constructor is in some way fundamental and the other constructors are more about convenience, you might break it out as a static method which returns an instance of requester or something like that. So often you find that one constructor is the real one and the others are convenient. And in Kotlin, that's enforced. So in Kotlin, there is only one main constructor. And then you can define other constructors, but all the other constructors must construct this class by using the main constructor. So they can do some work first or something like that. But they have to use this, they have to call this in order to construct the class. And that might feel like an annoying constraint, but I feel like it's quite a nice constraint. Because it allows us to express quite clearly what our class actually is and what's just fluff around it. I also find that generally my test code will call the main constructor, because in that case I've probably built a mock HTTP client or something like that. So I want to pass in the kind of fundamental building blocks of this class rather than having them built for me in some way, because they might not be the right thing. They might not be the mock or the fake. Does that make sense? So yeah, this went along with my own thinking about what a class is, what construction is, but it helped me. It's convinced me that this is a good way of thinking about how to make objects. Because that primary constructor is the one that really explains what the object is. So by enforcing that structure, I think Kotlin is pushing you towards a style that is clear about what you mean. There are two things we call constructor, maybe. Okay, so streams. So in this example, we're going to choose our hot customers. We're going to do that based on what type of drink our customer drinks. If our customer drinks a hot drink, then our customer is a hot customer. And we're going to do it using streams. So customers is a list. We want to filter that list. So this is fairly declarative code, right? We want to filter our list based on whether the drink of that customer is a hot drink. The way we decide whether the drink of that customer is a hot drink is we stream hot drinks and we ask, is there any match to this predicate? And the predicate is a lambda function saying, does their drink contain, does hot drinks contain any, yes. Is there any hot drink which is contained in the customer's drink? Okay, so it's really easy to read. And then once we've filtered the customers, we then want their names of those customers. Why do you think I've highlighted some things in red? Because they're horrible. I've been doing a bit of interviewing candidates recently. Come and work at Open Market, it's really good. And one of the things we do in our interview process is we have some exercises where we work with existing code, but we also have some exercises where people write a little bit of code from scratch based on a problem that they're trying to solve. And quite naturally, when you write exercises like that, they tend to involve lists and structures like that. So you can see it happen in the candidate's mind. They think, oh, this is a list, I should use streams because I'm going to look really good. And what generally happens is they go, so they're allowed to use an IDE, so there's some chance of getting it working, right? They say, oh, I'll use streams for this. And then they type .stream. And then sometimes they might type something like .filter. And they might fight their way through it. And then they get to the last line. And who can remember what collector you use to get the stuff out of a stream? Let me tell you from my experience of that process. No one can remember what collector you use. So then at that point, they delete it all and they write a for loop. And I think, yeah. At which point, that's a hire, right? Because the for loop is like 3 lines long and it works. Anyway, so this is Java streams. The reason the conclusion I've come to is the reason why it's never a good idea to use it is because that last line is too difficult to write. So in Kotlin, you just don't write it. So that's the equivalent code. And it knows what you meant. So yeah, I've got some customers. I want to filter them. And the way I want to filter them is to say, does their drink contain any of the words in hot drinks? Notice, by the way, a slightly more compact way of writing the lambda as well. So the lambda on the previous slide has an argument drink, which gets passed through, confusingly the same as a property of customer, also called drink, which probably is what threw me off. Whereas in Kotlin, following the convention of some other languages, if you don't say what arguments, then the argument is called it. Which you could argue is confusing, but it's hard to argue it's not. Also, slightly easier to read in this case. Also, you can refer to a method. So on the previous slide, I referred to the method getName. So it's basically saying, once you get back customers, apply this method to the instance you've got, the getName method. You can also do that in Kotlin, but I think it reads better to just say it.name. We're seeing another feature of Kotlin here, which is that in terms of the equivalent of Java code that you're getting out of Kotlin, this customer object has a method called getName, but it's just that in Kotlin syntax you can just say .name and it knows that really it calls the getName method. But even if that code was written in Java and it really has a getName method, you can say .name and it knows to call getName. Is that scary? Yeah.
The eldest operator, it, and the getName thing were all stolen from Groovy.
So Russell's Groovy yeah. So Elvis operator, the it and the compressing getName to name are all stolen from Groovy. So. Yes.
Is the result of .filter a list or a stream?
The question is the result of .filter a list or a stream? Anyone know?
I think that's my point. In the Java, we know, because that's what the code says.
Yeah.
Here, you don't actually know whether it's creating an intermediate list.
Yeah, so the point is that you don't know you don't know the type of this thing. I believe it is some kind of streamable or iterable thing, which then the type, because of the type that's being asked for, it gets automatically converted. Generally, I'm against automatic conversions. If I have to choose between remembering what collector I'm supposed to use and having it know because of the type, I choose this one. I'd rather have something maybe more explicit. But, yeah. This looks good, right? This looks like you could write this code, I think. I like tiny little lambdas. I like lambdas to almost disappear. So they just look like just like a block of code that you would run. Cool, so it looks plausible you might use streams in Kotlin. That's my main point. Okay, so here's my summary. I need you to ask lots of questions after this because I've gone too quickly. So a lot of the things we've learned about how to write Java code, but are very laborious. In Kotlin, you can just have it. You can have your cake and eat it. You can have it written the way everyone expects your Java to be written. But you don't have to type all the characters to get it. So value objects is the kind of prize example on that, data classes. But also, the pattern of things that are immutable should be immutable is easy to do in Kotlin. Also, there's some chance of using streams because they read a bit more like the code they were inspired by in other languages. Similarly, for construction and for default parameters, instead of having to do all the typing of all these overloaded methods that take different arguments, you can just have one method that, and you can express clearly in the calling code which argument you're supplying and which one you're not. Secondly, null handling is explicit, so this enormous class of bugs at least requires you to explicitly write code saying, yes, I want a bug here, if you want to recreate it. And it is quite easy to use. It's critical that null handling not only be enforced, but also be easy to do right. Otherwise, you just manually type out the bad code. And also, it gives you some ways of saying what you mean, especially when expressions and things around, returning expressions. I love returning expressions. I would like every method to be one logical line of code, like in a proper language like Haskell. This is more of a discussion. So that's the end of what I've got prepared. But I wanted to discuss. I was hoping, as seems to be the case, there are people here who have thought a bit about this stuff already. Things that I would like to have in Kotlin. Some of the things I would like to have probably or possibly are not possible on the JVM. But these two, maybe we could have them. So can I have a way of marking a method to say this does not modify any state external to this method? Some people might name some languages that give you that capability. Could we not have that in Kotlin? What it would gain me, it would gain me a lot of feeling of security, but it would also gain me the ability to write a function that has been declared in that way and then pass it to, say, a parallel algorithm or something like that, and know for sure that I'm not going to get any weird problems. Yeah, I think the point is you need support from the rest of the system. If you had the ability to mark functions as pure and the compiler checked that, you could then write a parallel algorithms library that could make all kinds of assumptions, assuming that the thing you gave it was pure. That means it could run your stuff on a different CPU or a different computer without you knowing about it. Do I want to write impure? Starting from scratch, I would definitely want all functions to be pure by default in a similar way to variables being final by default, but not starting from where we are with interoperating with Java code. Yeah.
I wonder if what you're suggesting is I should use Fraser rather than Kotlin.
Are you wondering whether what I'm suggesting is we should use Frege instead of Kotlin? So who knows what Frege is? Who can guess what Frege is? Frege, if I can stop murdering the pronunciation, is one of the two competing Haskell-like languages for the JVM. You think the other one's dead?
Frege is Haskell on the JVM.
So you're saying Frege is the one that is Haskell on the JVM in the sense that it's compatible with Haskell?
Yes.
Okay.
So you can take Haskell code and potentially with one or two I/O functions,
Okay, so you can take Haskell code and it will execute in Frege. So I don't think I'm asking for Frege on the JVM because I actually want my company to adopt Kotlin. So there are two reasons why Frege doesn't do that. One is that it's too hard. So that's a problem that maybe we could get over by telling people, look, you think it's hard, it's not as hard as you think, or whatever. But the other thing is that the reason why it's feasible is because of the interoperability with Java. So one of the things that's really attractive about Kotlin is that not just the execution on the JVM, but the language itself is semantically close to Java. So when you interoperate with Java in both directions, it's not mad, So I mean, Clojure can interoperate with Java, but when you call a Java method from Clojure, you feel like throwing yourself out the window. Whereas in Kotlin, when you call a Java method from Kotlin, it looks like Kotlin.
I think I'd suggest that your first one there is actually inconsistent with the goal behind Kotlin, which is to be consistent with Java.
Okay.
Therefore, total purity is just not going to be part of the game.
Okay, so the comment is that by encouraging or even allowing declaring something pure, you're going far enough away from how Java works that you're actually using my previous point against that point. That's a good point. Yeah.
Saying about the inference ability, you said something, you did a test with not being null, then the rest, later on is type, automatic typing. If you could mark, if you had a way of saying something was deeply immutable, because the Balaam finding things, the only operator at the top level of it, right? But if you said this is really Val, then you could infer which things were pure, and then you wouldn't need to mark them. You would know, because you said this parameter is deeply pure, I'm deeply immutable, I'm not going to touch it, and then you could infer the purity, and then you could both.
Okay, so the point is, so the point is that we're already doing. Kotlin already does some inference on understanding what type your thing is. So we could have, if we had deep immutability, as in saying nothing inside this object can ever change, then we could determine whether a function's pure. Well, that's true except for when it uses global state and other evil like that. So I would like a pure keyword that means that accessing global state is a compile error. Yeah.
But then you have to do inference work to work out the declarer. I call this other function. Then this is my pure one. And I lost my pure.
Yeah. So the question is, how would you work out when you call a function? Is it when I call a function from within my pure? Yeah. So. I'd be happy to start off with, if you call a function, including a Java function, then your function is not pure, right? That would be a start down the journey of there's some code I can rely on.
That's where you're getting your close stuff, right? As soon as you call Java method, you're out. It's like you punched a hole in your function with bracket chain, haven't you? As soon as you leave closure to Java, all bets are off.
Well, I don't know whether. Why do I feel dirty when I call Java from Clojure? I think because it just looks wrong.
Well, that's why it looks wrong, right?
Well, I mean, maybe, yeah. But Clojure doesn't. Clojure's execution model is not that different from Java, except we don't bother with all these stupid type things. Other than that, but the syntax is so alien that it looks weird. But. By the way, Clojure is not the answer because types are really good. Just as a side point. Yeah, so my other thing is deep immutability, right? So, and I believe Kotlin native might have this. I was hoping someone might be here who. No one knows. But yeah, so I want to be able to say this in the same way as saying this variable, this name can't be pointed at something else. I want to be able to say nothing inside this thing will ever change. And I don't know, it feels like maybe the compiler can figure out that that's true. I don't know. Maybe not. Wouldn't it be great, though? Cool. Well, that's all I had for that. Any other questions or comments? Yeah.
I would dearly love to migrate someone who's been stuck in Java for the last 10 years to Kotlin. Would it be possible for them to take their somewhat dated Java and run it as though Kotlin? And then is there anything that tell them which makes their behavior better?
So the question is, I've got someone who's got an old Java code base. I'd like to move them onto Kotlin, and when they've moved onto Kotlin, can they then see how to improve their code? So the IntelliJ IDE will automatically convert your Java code to Kotlin, and in some cases, that's quite bad Kotlin. Because it preserves exact compatibility, or at least that's my understanding. So that means you have to write quite bad Kotlin in order to do all the bad things you were doing in Java. But it also gives you quite a lot of warnings and hints about how to improve your code, so you'll get some way with that. But when I haven't done it with much, I've done a little bit of converting Java to Kotlin. It did produce quite bad Kotlin that I then had to manually think, no, I know there's something in Kotlin that's better than this, and I'll do it that way. So I didn't feel that just following the warnings would have got me to good Kotlin. I don't know how to avoid that. Just read the Kotlin website and think, oh, wow, that's really cool. And then, yeah, definitely have it reviewed. Yeah.
How does the interoperability work? Do you have to convert the whole Java project into Kotlin, or can you?
So the question is, how does interoperability work? So it's unbelievably seamless. It's brilliant. So if you have some Java code, you just call it from Kotlin. There's no bridge. And if you have some Kotlin code, it compiles to a jar file with .class files inside it, and you just call it from Java. And the only thing that's different is that the way of doing things like get look different in the different languages, but underneath they're doing the same thing.
But you should have a single language for a single artifact. So you should create a Kotlin Java. You should have your Kotlin project which creates Java.
Okay, so the question is, should one thing be in one jar? And Russell is shaking his head. So.
One of the early principles in Kotlin, which meant they got rid of the Java symbol and stuff like that, caused the seamless calling of Java, is that you have class-by-class basis, so that you move your Java code, given a class, you then can create a Kotlin class, and then you can tie it all up into a single entity. And it literally is piecewise moving from Java to Kotlin. And this is not me just waffling. This is based on the experience of doing the DIM plugin to the IDE. And it was a massive Java. And piecewise it can move over Kotlin.
Yeah, so I'm just going to repeat some of that for the video, but yeah, you can do it class by class. So my first use of Kotlin in a not toy project was a very crufty old bit of Java that we have that was an IRC bot and is now a Slack bot in our Slack channel. It's great code. It goes back a long way. And it was awful Java 6, and we got it compiling with Java 8. But I just took a class and clicked the convert to Kotlin button in a project that had no idea what Kotlin was. This is in IntelliJ, which is written by the people who designed Kotlin, but you definitely don't need it in order to do Kotlin. Otherwise, I would just not even be here, right? But yeah, you click the button and it transforms into Kotlin, and it also modifies your build setup so that you have the jar files you need for that Kotlin code to work correctly. And to compile, it modifies the build stuff so that it knows how to compile Kotlin. And if you've got a build setup that is not IntelliJ, like a Gradle or a Maven setup, it modifies your Gradle or your Maven setup so that it will build on the command line. So they've done everything to just make it be fine, which was very clever of them, because otherwise no one's going to move, right? So it's surprisingly good. Cool. Yeah.
Another almost literally.
Yeah, so the Java community is copying stuff from Kotlin, which then leads to the concern that when I'm advocating Kotlin at work, people are saying, well, can't we just wait for Java to do it all? But I don't think you're going to get the null stuff, right? This dual type hierarchy, which when you think about that, when you describe it like that, doesn't sound that good, but actually it's quite good. Maybe not the best way of doing it, again, if you were starting from scratch, but definitely the best way I can think of to do it, given you've got existing Java. That some of the stuff that Kotlin does just won't be doable. And also some of the little things, like the way closures look, they're probably not going to copy because they've already got a way of doing that that is almost as good. Yeah. And the streams thing, within Java, how are you going to rescue streams from the mire that it's in? I don't know.
The problem there is you've got sequential streams and parallel streams. And your example is very much in sequential streams.
Yeah.
And parallel streams and parallel streams.
Right. Okay.
The only person in the world using parallel Java streams. All the rest of us are doing stuff like that.
And until and only really in programming interviews, right? You'll get there.
30 years, it's all been lists. I've got some stuff in a list, I need a bit of that list. It's all with most not doing computer science. We just got lists and we need one list or short.
Well, once we have pure functions, we can have parallel stuff, right? So it's all just list processing, is what you're saying, yeah.
Yes.
Cool. So if you have to live in the Java world, maybe Kotlin can make your life slightly better in a way that your colleagues will accept. That's all I've got for you. Thank you.